So this is the homework too. You can see that on the top is covering section 4.1, 4.2, sample space, and those probability questions, right? The first one, the percentile corresponding to a given data x is computed by adding the 0.5 to the number value less than x, and then dividing by the total number value in that data set, 2, right? And then find out the z-score, right? That's straightforward. Apply the z formula, find out which z-score is higher. That one is still z-score, right? A baseball player has the batting average of 0.325 each week, with the standard deviation 0.062. What's the z-score when he bat 0.410? So apply the z-score formula directly. What is the set of all possible outcome of a probability experiment, right? What do we call this? Sample space that has all the possible outcome together. The average weekly earnings in dollar for various industry. Okay, find the percentile rank for this number 683. Remember, how do we find out the percentile? We want to put those sequence of number in order and then apply into the formula, right? To see how many value they are less than 683. I'm not going over details for that, everybody. So as long as you can go back to the example we mentioned from the next notes. That should be pretty straightforward. How many possible outcomes would be there if 3 coins were tossed once, right? So how many total possible outcomes if 3 coins tossed, right? So the first coin, how many output? 2. So if we want to write down that, the first one, you have 2 choice, first coin, right? Second coin, 2 choice, head or tail. Third coin, how many choice? Head or tail. Multiply them together. Remember the fundamental counting rules. 8, right? And then that's 3 dollars.
Professor?
Yeah. Go ahead.
How is it number 8? Because doesn't a coin just have one side and there's 3 coins? When you flip all of them, only one side of each coin will show. So it's just 3 sides.
One more time.
For number 6, if there's 3 coins and you toss them all at once, and they land flat, each coin will only reveal one flat side of itself. So isn't it 3 flat sides will be shown, 3 outcomes?
When we say one outcome, that is considered as like you have 1, 2, 3. You have a 3. This one is a head. This one is a tail. This one is a head. That is considered as one outcome.
Yes.
Okay.
Oh, the outcome, heads and tails. Okay.
So the question is asking how many outcomes. So to answer that question, remember how many outcomes we can use the fundamental counting rules. For the first coin, how many possible outcomes? We have 2. It's either head or tail, is that right? Second coin is either head or tail. Third one is either head or tail. And then we multiply them. We got 8. Still confusing?
No, I understand. It's the outcome and not the flat sides, like the faces.
Okay.
What are the probabilities?
Okay. Those ones I'm not going to go over this. That should be pretty straightforward. Now, let's see. If the probability of raining tomorrow is 39%, what's the probability of not raining tomorrow, right? That's very easy, everybody. 1 minus that, 61%. Tree diagrams are very useful for A, find out all possible outcomes in a probability experiment involving several steps. That should be the one, right? Find the probability of getting a number greater than 4 when a die is rolled one time. So, right, the probability is something divided by something, right? So we have, if we roll a die, how many possible outcomes altogether? 6 is right. The denominator is 6. Now the numerator is, what are we asking? We want to ask the case that is greater than 4. So we have like 5 and 6. How many? 2. So 2 over 6, simplify that, it should be A, 1 over 3. Yeah. Now let's, some questions relatively simple. I'm not going details for that. Now for number 13, it's a little bit tricky here, everybody. I want to mention that. If 2 dice are rolled at one time, find out the probability of getting summation of 6. Okay. Remember, probability is always something divided by something, is that right? Denominator is total possible choice. So if we roll a dice, right? 2 dice, right? What's the outcome for the first one? Everybody? 6, right? What's the outcome for the second one? 6. By the fundamental counting rules, that's how many possible outcomes we have in the denominator, right? The question is in the numerator, how many possible cases we are asking? We are asking getting the summation to equal to 6. What does that mean? That means say you have 2 numbers, adding them together, you want to get 6, right? Think about how many situations you have that. If here's a 1, here must be what? 5. If here's a 2, 4. 3, 3. 4, 2. 5, 1. How many cases you have here? Yeah, 1, 2, 3, 4, 5. 5 cases possible. That's the one we are asking. So the answer should be 5 out of 36. The answer should be C. Follow me? Number 14, 416 students. 170 say they, that's easy. I'm not going over detail for that. There are certain questions I feel is interesting. Those one not. All right, those are pretty straightforward. Not cover that. Okay, I do want to cover number 19 here. A single card is drawn from a deck. Find the probability of selecting a heart or 8. Everybody? Right? So remember, probability is something divided by something. So in this case here, we have let me see where it's more. So we have the, so denominator is how many possible choice we have, right? We select one card out of a deck. How many choice we have? 52. Denominator, right? And then numerator is number of cases we are asking. Everybody? We are asking, we want to get what? A heart or 8, right? Let's think about that. How many heart we have in a regular deck? Everybody? Is 13, is it right? Is that 13? Right? Like a suit is called a heart, right? So 13. Now, and then plus 8, right? How many 8 here we have? Be careful here, everybody. Right? There's a 1 heart 8, is it right? So in other words, we cannot count that again because that one is included in the 13. So there are 3 extra 8 here available. Follow me? Right? So the answer should be 16 over, let me see, 16 over 52. Do we have an answer here? So we try to simplify that, right? So both sides divided by 4. So we got a 4 in the numerator. In the denominator, got 13. So it's 4 over 13. The answer is A. Follow me? So that's the tricky part, everybody. When they are asking the probability of getting hot or 8, right? So it's like a probability of A or B. Everybody, if you want to do that, it's also okay, right? Probability of A or B, right? You want to use that formula we mentioned last class, right? You find out PA, PB, and PA and B using that formula, right? Or you just this way, and it's an easy one, right?
Professor?
Yeah.
In that circle that you made on the left-hand side, isn't that PA or PB, but not together?
When we say PA or B, that means what? That means together.
Two separate groups.
When we say, remember the ones that we mentioned previously, right? Say it's a Venn diagram.
Mm-hmm.
When we are asking what's the PA or B, which region we are asking, right? Let's slow down a little bit. If I'm asking, this is A, this is B, right? Now I'm asking PA or B. So the region we are asking is what? Is this area here and this area here. Is a what? Is a union. Follow me?
Mm-hmm.
Right? So that's a PA or B. It's like all of them here. Follow me?
Yes.
Okay. So that's the reason when you have 13, it's like you already covered the intersection part already. Then when you add this extra piece here, you want to exclude this one, right? So this 8, there's 1 8 that is a hot. So there are 3 other 8. So that's the 3 ones here.
Mm-hmm. Mm-hmm.
Okay.
Oh, so you've already excluded it in that +3 instead of saying +4.
That's right. So if you don't do that, you have to use the 13 plus 4 minus 1.
Yeah, now I see it.
Yeah.
So you took a shortcut, basically.
Yeah. So, I mean, you can use either one. Yeah. I was trying to be lazy. Okay. Again.
Are we going to have questions like these about decks of cards on the exam? Because I'm not quite too familiar about decks of cards.
Yeah, that's the one we mentioned, that you don't have to be expert in the casino, but you do need to know basics about the card game. So since we have some questions here, right? So that means most likely we will have some questions for that coming exam. Okay, so make sure you feel comfortable. Now, number 20, I want to mention that this is a tricky one. If one card is drawn from an ordinary deck, what is the probability that a card could be a king of hearts, or a spade? Everybody, be careful here. So let's do that slowly, right? Denominator is always easy, 52, right? Because you select one card, okay? Now the question is, in the numerator, what's the probability of a card? Could it be an A? How many A we have, everybody? 4. A king of hearts, how many of that? It's
4.
only 1.
Oh,
There's only 1, right? Because there is a king and also is a heart, right? So it's specified, there's only 1, right? Now, a spade, everybody. Spade, how many spades we have? We have 13. Is that right? We have 13 spades. Be careful though. Those 13 spades here, they do have 1A, do they? that 1A is right. So we don't want to include all of those because I count this 1A already. So you see, we have 4A, we have 1, that's the king of hearts, and then we have a 12. So add them together is what? How many? 17? That's 17? Oh yeah, that's 17. 17 over 52. You can double check your answer here. The answer should be B, right? Follow me, everybody? Be careful here. We don't want to have the double count case, okay? So someone was trying to say, we have 4A, we have 1 king of heart, and then we have a 13 spade. Add them together, you got 18. The answer is 18 over 52. That's not right, everybody. That's not right, because we do have a double count. When you say a spade, remember, it's 1 suit, right? A spade, that means there's 1A over there. Right? We don't have to worry about this case here. Why? Because they're talking about hearts, right? Right. So this one is a spade. Very tricky though. If here they say is a king, they don't say king of hearts, then we also have to minus 1 here too, right? Because the king, potentially we have 1 case here. So how many? We have 4A here, 1 king of hearts, and the extra 12 spades, everybody. Okay, extra 12 space because we don't want to include that A. There's 1A here, is A of a spade, right? We don't want to include that. The answer is 17. All right, that's for this case here. Let's see. Those are the, you can apply the formula directly. It's not that tricky. This one. Number 22, I do want to mention that. We got those questions. So some university, 500 people, right, enrolled in that both classes. Out of those 566 receive A in chemistry, 73 receive A in calculus, 33 receive A in both. Find out the probability of randomly selected students, right, receive A in chemistry or calculus or both. Everybody? So this is the only confusing part for some people is like when they say or both, right? That might confuse you. So what they are essentially asking you is what? Is simply the formula we just learned, right? We are trying to calculate what is the P, A, or B. That's it. Right? So when you say probability of A is happening or B is happening or both, that means that this both is what? It's also included that here. Is that right? So that's the tricky part. Don't get confused, right? We are simply trying to get this one, right? So you plug each formula here, right? What's that equal to? It's equal to PA plus PB minus PA and B, right? Remember? Minus PA and B. Forgive me, it's difficult to write on that here, right? PA and B. Now, we know each part actually. What's PA? That's 66 over 500. PB, that's 73 over 500. A and B, that's 33, right? A and B, they got A from both. So A, this event and that event, minus 33 over 500. So I'm not going to cover the details, everybody. The only confusing part is that both sometimes confuse you, okay? Now, I'm not going to cover that. That's pretty straightforward, right? Add them together because because they are mutual exclusive. Let's see, we have Okay, number 24, I do want to mention that, everybody. Number 24, what is the correct relationship between those two events? A, Carl is a college graduate. B, Carl is a high school graduate. Let's check out. A, B, option A, right? A, B, are they mutual exclusive or not? Mutual exclusive, that means these two events cannot be true at the same time. That's not right. I mean, Carl could be a college graduate. Carl could be a high school graduate. Both could be true at the same time, right? A is not right. B is the complementary of A. So that means they are opposite. Not really, right? I mean, what's the complementary of A? Carl is a college graduate, right? What's the complementary statements? Should it be Carl is not a college graduate, like that, right? Okay, so now the tricky part here is C and D, okay? C, A, B, they are not mutually exclusive. That's actually right, is it right? We know it's possible for both of them to be true, right? So they are not mutually exclusive. C is right. How about D? That's the part some people got confused. If B is not right, if B is not true, that means if Carl is not a high school graduate, so Carl cannot be a college graduate. Is that true or false? That is false. Everybody, be careful here, right? So we have those homeschool case, is that right? Homeschool. You don't have to go, I mean, you don't have to graduate from high school, but you can still go to college. Okay, so D is not right. The only answer here is C. Okay, so there's, I mean, this case here, someone say, oh, we have two correct answers, C and D. No, that's not right. And let me see, the other ones are pretty straightforward. I'm not going to cover that. Number 29, I do want to mention that. Let me see. We have $29. A die is rolled 4 times. Okay. What's the probability come up one at least once? Come up one at least once. So how do we solve that, right? Remember, whenever we have these at least questions, we always think about the opposite, right? So that means what? The opposite event will be out of those 4 times, 1, 2, 3, 4, right? You never got 1. The 1 did not show up. So in other words, you have 5 out of 6 here, the first one, because you don't get 1, right? Same as the second one here, you got a 5 out of 6. What is the probability, right? Here, same, 5 out of 6, 5 out of 6, and multiply them together. Is that the answer? No, because this is the opposite event. So we are using 1 minus that, okay? 1 minus that, okay? The 5 over 6, I don't think that's 0.4 though, right? You want to double check that. If someone try to say 5 over 6 is equal to 0.4, that might not be right. Okay, double check that. Now, the other one are similar. I'm not going to cover that here. When you say at least, right? At least, similar, okay? And that's easy. I'm not going to cover that. Those are easy ones. Let me see. Okay, number 34. I do want to cover that here. Number 34. In some healthy home, okay? 10% of the residents, they play shuffleboard. I don't know even what's that, okay? something, okay? 35% they play poker, okay? I know that. 15% they do some gardening, okay? Now, if 5% of residents play poker and garden, right? Like both. Find out the probability of a resident play poker given they also do the gardening, right? Remember, this is what? This is a conditional probabilities, right? Given. Whenever they say given, that remind us is a conditional probability, right? Probability, you can see this is a probability of play poker. You can using capital P here, right? Given they are doing the gardening. Follow me, right? I'm using capital G for gardening, right? But the formula is what? The probability of poker and gardening. Find out that probability. That's a numerator, right? Divided by probability of gardening. Okay, everybody? As long as you plug into this formula, you should be fine. Why do I mention this question here? You will realize you only need two probability here, right? Probability of gardening, what's that should be? 15%. That's the number you can use in the denominator. Probability of do the poker and gardening, so that is 5%. Remember, right? Then some other people are confused. What's happening for this 10%? What's happening for just 35%? Why they are here? If we don't need that, right? Why they put that here? Why? Because they are trying to confuse you. Okay. Don't blame me.